So we are talking about K-medoids, which is going to be our second method in the partitioning method for clustering. So when you talk about medoids, the significant difference between K-means and K-medoids is that in K-means we are using centroids, and in K-medoid we are using this term which is known as a medoid. Now what is a medoid? A medoid is that number whose dissimilarities with the other data points is going to be the minimum. So you'll understand this more. Let's just look at an example first. So this is what the data is given to us. So we have total of 10 data points and the x and y are represented over here respectively. Now we have to have two clusters formed. Okay, so just like we did with K-means, here also we are going to assume two centroids or two medoids. In this case it is going to be medoids. So what if I decided to be this one, that is 3,7, and this one 4,5. So I have taken data point 1 and data point 9 to be my medoids. So again I'm going to create a table. I'm going to write here C1 and this is going to be C2, and this would be whatever cluster this is going to go. It can be either in C1 or it can be in C2, right? So we get started. What are we going to do now is we are going to be finding the absolute distance. So this is C1. C1 is, let's just get rid of this thing here. So our C1 is 3,7. Okay, so this is the value of x, this is the value of y. Here also we have x and y, so we are just taking the absolute value. So that is going to be the mod of 3 minus 8 plus the mod of 7 minus 7. This is going to be the answer over here. So 3 minus 8 is minus 5, so mod of minus 5 is plus 5, plus 5 plus 0 is going to give you a 5. This here you won't have any values because you have taken them as your medoids, right? So next one is going to be 3 minus 4, that is 1, 7 minus 9, that is going to be 2, so the answer is going to be 3. Similarly I'll solve over here. So now for C2 we have the value as 4,5, so that is going to be 8 minus 4, which is 4 minus 8, 8 minus 4, that is going to be the same thing. So that's going to be 4 plus 2, which is 7. So here there can be no values. This is going to be a 4. Then you have over here 6, and this is 4, 4, 5, 5, and then this is going to be a 3. So we have gotten these answers. Now we are going to be comparing these two. So 5 and 7, the least one is going to be 5, so this is going in C1. Now this was the medoid, so this one will obviously be in C1, right? This is also going to be in C1. This will be in C2. This again C2. This will be in C1. This is going to be in C2. The next one is in C2, and the next one is also in C2, and the last one, of course, that was the medoid, so this is going to be in C2. So now the two clusters that we have, C1 is going to have data points, so let's just write them down, the data points itself. So that's going to be 8,7, 3,7, 4,9. The remaining data points that is going to be are going to be in the cluster C2. So now what we have to do is we have to find their costs. So cost is going to be nothing, it is going to be the individual costs for all of the terms in C1. So that is going to be your 5, 3, 3 plus, so that is it. So that's going to be 5 plus 3 plus 3. This gives us 11, right? This is the cost of C1, right? We repeat the same for the cost, the total cost in cluster C2. So that is going to be 6 plus 4 plus 4 plus 5 plus 5 plus 3, which gives us a 27. So now what we have to do is we have to find the total cluster cost for the medoid values. Excuse my handwriting right now, guys. It's 3,7 and 4,5 equal to this 11 plus 27, which ends up giving us a 38. So this 38 is for this cluster value. Now what I'm going to do is I am going to take a test medoid value. Okay, so we already had selected these two medoid values, right? 1 and 9. Now I'm going to take another value. Let's just call it O dash. So let O dash be your 4,9. So 4,9 is my second Kmedoid value, right? So what we are going to do is we'll make another table just like this, okay, and then we also have to repeat the same process, and we have to find the distance between the two. So I'm just writing it down over here only, but you have to, obviously there is going to be a change in your table, because here this value will be calculated now. The value for the ninth data point will be calculated now, and you won't be calculating the value for your 4,9 because you have selected it as your Kmedoid value right now, right? So I'm just making changes in this table. You all have to make a different table, remember this, okay? And I'll have the cluster part made over here only. So this would be the cluster. So you can have the cluster for your 4,5, and here it would be the cluster for 4,7. Okay, let's go ahead and quickly we'll find the values for when the cluster value is 4,9. Oh, it is 4,9, not 4,7. My mistake. So this one is again not there, and 4,9, so we won't be having, and we'll have to find this value. So this is 3,7. So 3 4, that is going to give you a 1. 1 plus 2, that is going to give you a 3. So now we'll quickly write down these values. So that is going to be 4 plus 2, that is 6. Now this is going to be 5 plus 3, which is 8. 4 plus 4, that is 8. 1 plus 1, that is 2. This is going to be 3 plus 6, that is 9. This is going to be 4 plus 5, that is going to be 9. This is going to be 3 plus 4, that is 7. And then this is going to be 4. So now that we have all of these values, we're just going to write down the clusters that they are going to belong to. So this is going to be in C1. This is of course in C1. This would be in C2. This one is going to be in C1. Again C1. This is going to be in C2. This again is in C1. This is in C1. This is in C1, and this is again in C1. So we only have 2 values in C2. Rest all of them are in C1. So let's go ahead and find the cost again. So the cost for C1 is going to be 5 plus 7 plus 7 plus 8 plus 8 plus 6 plus 3. Let me show you how that is happening. So this is going to be 5 plus 7 plus 7 plus 8 plus 8 plus 6 plus 3. That is what is written over here, and the cost comes out to be 44. Okay, and then C2 is going to be nothing but you have these two over here. So but you cannot have this value here, right? Because it's not there. We cannot calculate the value. This is going to be just 0. So here you have this other point which is going to give you a 2. So now we have the total cost. So the total cost comes out to be 44 plus 2, which is a 46. Now so this one was for O dash, where O dash was 4,9. Right, we had the total cost earlier, right? The total cost was 38. So 46 is greater than 38. This means that this value, the value 4,9, the dissimilarities of this Kmedoid with rest of the points here is going to be much greater than the dissimilarities that these 2 points had. So what I basically mean is that this point here 4,9 is going to be a lot more dissimilar when you compare it to these 2 points. So we stop here. Okay, so we are stopping here. There is no swap happening. But let me tell you, if this value were to be 36, then you say that 36 is less than 38. That means that your 4,9 is going to be a better Kmedoid value when you compare it to your 4,5 and 3,7. So we would have continued it further. We would have taken a different number and we would have proceeded with the same calculation like we did over here for distance, right? So that is it. I'll repeat this entire thing once again for you. We have got these data points over here, and we were asked to have 2 clusters formed. So we took 2 values. This is a K-medoid problem. So we are dealing with the Kmedoids, and Kmedoid is going to be that point whose dissimilarities with the other points is going to be less. So we have taken 2 points. In this case we took 3,7 and 4,5. We calculated the value of C1 and C2, and then we took their cluster range also. So we got 11 for C1 and we got 27 for C2, and then we took their addition, that was 38. Now we had to check if we could find a better Kmedoid value, the cluster of the cost of the entire cluster, if it has to be less or not, right? So we took another data point 4,9, which is this one. Again we repeated the same process. We calculated the distance, and then we saw in what clusters the data points are falling, and then we again calculated the cost and the total cost. The total cost for 4,9 came out to be greater than it did for 4,5 and 3,7. So we stopped our calculation over here because 4,9 was bringing a lot more dissimilarities to the calculation than these two did, right? So that is it for this video, guys. This is how you are going to be dealing with the K-medoid problems. That is it for this video, guys. I hope you've understood how to solve K-medoid problems. So make sure that you're solving a few different kinds of these problems, just so that you get a clarity about these topics, because K-medoid and K-means, these two are very important and they do get asked in the exam every single time. So even when I was solving this problem, you can try to take a different medoid to see what result you are getting, because everyone, depending on the medoid that they select, the answer is going to be different. Also, I just wanted to mention that I know that my audio sounds a little weird in the entire explanation. That is mostly because this was filmed during my exam time, and thus the voice. But I hope you can ignore this and you have understood K-medoids. If you have any doubts, as usual, don't forget to write them down in the comment section. That is it. Bye.